Hello, welcome Jefferson students. It's good to see you guys again here on a Wednesday in day 3 of week 3 of our e-learning. As we always start off now, we see our go blue, but before I get there, just for a few announcements, the same as yesterday. Again, don't forget, we are halfway through our video lessons for the week. We will be having our unit quiz on Friday. That is our assessment day, where we will not have a video lesson. So one more video lesson after today's for the rest of this week to finish off as we get here 3 weeks into the e-learning. Not only that, guys, again, grades are still being up to date, so I'll be getting through hopefully most, if not all of those today. And then the lab, moon phases lab, which today we're actually going to introduce the moon phases, or the moon specifically with tides, talking about the kind of introducing that today. So again, your moon phases lab that I went into great detail on Monday as well as Tuesday, that is due on over the weekend, by the end of the week. So the quiz starts Friday, not due to the end of the week though. You get one try. Remember, with quizzes, you get one opportunity to try it, and you only have a 1 hour time limit. So it'll be open Friday. You'll be able to take it Friday, Saturday, or Sunday. Okay, our questions. Number 1, what are Newton's second and third laws of motion? Again, we just finished up all of our laws. We talked about Kepler's laws. Now we got to know Newton's laws. 2, what 2 factors determine the gravity of planets? And then 3, what is centripetal force? Again, my first picture kind of relates to some of that gravity stuff, and then my second picture down here kind of relates to maybe one of Newton's laws. So go ahead, pause, take a moment to write those out on page 8 or AB. I know a lot of you may not have enough room on page 8 because you've already had a lot on it. So you can go ahead and move that to page 8B. But let's go to our answers here for our Go Blue. As you guys can remember from the other day, for, again, number 1, and we've already written this down, so no need to necessarily write it all over again unless you feel necessary to help test yourself and help kind of test your memory a little bit. So second law, anytime we think of second law, I want you guys to think of force, right? Again, think of that classic formula a lot of us have learned time and time again. F equals m times a. Again, when a force acts on an object with its mass, like a bowling ball rolling down a bowling lane, right? Its acceleration, its force is going to be the mass, how heavy the bowling ball is, times the acceleration. How fast is it speeding up? That's going to determine the force of an object. And then third law, to every action, a little more simplified than second law. To every action, there is simply an opposite reaction, right? So for example, in boxing, right, boxer's going to practice punching a punching bag, okay? He's throwing a punch, he's got that action, and then the punching bag gets moved back and swings back as well. That's a reaction to that. Again, action, reaction, Newton's third law. Number 2, simply put, what determines an object's gravity, or specifically a planet's gravity? 2 factors. It's going to be the planet distance, how far the planet is from the sun. So the farther the planet is from the sun, that's going to cause it to have less gravity. But more importantly than that, it's going to be actually the mass of the planet. You guys saw from your video about if Earth were twice the size that it is now, what would happen? The larger the planet, the stronger its gravity, right? So Jupiter may be farther, but it might actually have, I believe, if I'm not mistaken, a stronger gravity, obviously, compared to the Earth, because it is the largest planet in our solar system, right? So again, distance, but also more importantly, mass determine a planet's gravity. And then our last answer here, guys, what is centripetal force? The inward force causing an object to move in a circular path is its centripetal force. So again, an object isn't going to move in a rectangular fashion. It's not going to move kind of in a non-uniform fashion, okay? You're always going to see the slight curvature of an orbit where a planet's going to curve in and make that circular, make that oval-shaped kind of pathway. We call that, again, from gravity pulling on it steadily as it goes around, we call that centripetal force. And gravity keeps the planets in orbit around the sun. Again, without that gravity, Planets would simply orbit, or they go around the solar system aimlessly in an ununiform and unorganized manner. Again, gravity is what keeps our solar system intact. Gravity is what keeps our solar system organized, right? Okay, go ahead and update your table of contents, guys. I believe this is the last update of this unit. Again, I took unit 7 and separated it into 2 parts. Don't forget the notebook check is next week. So we'll have a little bit of unit 7 and a little bit of unit 8, if I'm not mistaken, for next week's notebook check. We'll start unit 8. But yeah, moon phases will be page 10. I'm actually going to have you guys copy down those moon phases here after our first question. Okay, little Sonic the Hedgehog there on the right, Sonic Adventures. Number 1, which term describes the rate, again, this is a definition question, describes the rate at which an object changes position. So the rate of change of position, which involves distance over time. So maybe a hint, maybe an example of that would be miles per hour, right? Is it A, speed, B, acceleration, C, velocity, or D, incline? Take a moment, think about it. See what you guys have. Pause. All right, let's go ahead. Answer is going to be A, speed, guys. A, speed. Again, speed is distance over time. Acceleration is, or velocity is the speed in a given direction. And then acceleration is the rate at which speed increases in a given time period. So the rate of increase is acceleration. Distance over time is just speed. So a little more simplified there. An incline, that was just kind of an answer there to just throw you off, right? Okay, so on page 10, hopefully let me get my screen up here. I want you guys, again, you guys should already have these down after completing our lab, but to help you with the lab, all I want you guys to do on page 10 is title page 10, Moon Phases, and I want you guys to draw each of these moons and then sketch them each out. So we're going to go over these in more detail on tomorrow, our last video lesson of the week. But go ahead. We need to know each of these 8 moons and what they are categorized as. You're going to see a lot of questions on the quiz, future quizzes this week and next week's, showing you potentially pictures of just the moon itself. And I actually think, yeah, I've got to check out the EDSB and kind of format things, but I'm going to look to actually give you a blank image of moon phases. You have to identify which is which. That'll be a lot of questions on our quiz this Friday and next Friday. So we all know full moon again, but other categories we'll need to write down and know are waning gibbous, third quarter, waning crescent, new moon, waxing crescent, first quarter, and waxing gibbous. I'm going to go ahead. You guys draw those, write those out, think about them, even kind of quiz yourself on those a little bit, identifying the image with the moon itself. I'm going to go over those in more detail, though, tomorrow for tomorrow's lesson. So, again, something important we need to know. And, again, this ties right in to our moon phases. We'd be in the lab. We'd have the different styrofoam moons to really look at and compare and kind of show that relationship between moon and sun from there and how that shows the different phases. What I also would have done is give you guys Oreo cookies, and we'd actually divvy up the icing. So you would obviously eat your icing to make the different phases for fun as well. Why not? Just to give you guys each an Oreo cookie in class. So let's go ahead. Our first set of video questions for the day. Write this down on page 8 or 8B or 9 if you really need a lot more room. Number 1, how does the moon create tides? Again, the phases we'll talk about tomorrow. Today, I want to focus on tides. And then 2, what sun and moon positions are needed for spring and neap tides? So we're going to need to know different categories of tides. Today, I'll go over lunar tides and solar tides. But first off, before we begin, what is a tide? What is a tide? And I'm not talking about the laundry detergent, obviously, right? Let's go ahead and move on. Again, before I move on, let's actually check out a little snippet of this video. Again, I posted these already to EDSB. So go ahead, you need to watch this on your own for our notebook, for our notebook check and our quiz. Again, a lot of times I put these questions on quiz questions, right? And here's a little snippet again, how do tides work here. So enough of me rewinding. Okay. So all has to do with the gravitational pull between the sun or the moon, especially the moon, especially with the Earth, right? So really answers us as to how we answers our question as to how we get tides. It's all about gravitational pull, like I said, between the moon with the Earth and the sun with the Earth, right? And then the second part of this will go over spring and neap tides as well. So it's your guys' responsibility to get that on your own. Let's go ahead and go back to something I wanted to discuss here. Where are we at? Where are we at? Hold on. I'm sure I don't get us too lost here. Okay, so let's begin. Again, I would have made kind of like an organizer to get down our tide stuff. Um, but to get us going or to start us off, okay, so what are tides? We all know tides are simply the movement of the ocean's waters, the ocean waves to the beaches or the land areas of the earth, obviously, right? So what is causing that? Why isn't the ocean just peacefully sitting still? Why is the ocean constantly moving, constantly flowing with these waves, with these tides? As you just found out, oh, and another thing to think about, the video we just watched just talked about which impacts more, or talked about the moon and the sun. Those both create those ocean waves, those tides. But what impacts more? Okay, we'll find out here in a second. But really quick, tides are the periodic rise and fall of the sea levels, right? The periodic rise and fall of the oceans, okay? Again, always happening. It's never just sitting still, okay? What's causing that? And then high tide is the highest level which it rises. Low tide is the lowest level which it rises. Yeah. So go ahead, write those three terms down on page 9. That is new. That wasn't on our vocab. Again, that is new. We need to know tides, high tide, and low tide. Kind of common sense as well. All right. What I want you to do as well is on page 9, I'm going to have you guys, we were to do an organizer for this, but because we're still in e-learning, obviously, I need you guys to draw each of these tides for me. Okay, super important. So go ahead and draw the spring tide, and you're going to label these as such, and label, again, just copy this to it, copy this exactly as is with the different, and like obviously maybe a lot of you won't color your different components here. So what I would do is draw 2 big circles, label sun, earth, and moon, and then a small circle moon, right? And then you would say spring tide, full moon. Keep in mind, and this will help you with, actually this helps you with 2 of your lab questions. If you guys recall a little bit, ask you about solar and lunar eclipse a little bit, which we get, I believe, a solar eclipse with a spring tide, a new moon, and we get a full moon with a lunar eclipse. Okay, so we can see here. Oh wait, no, my bad. The lunar eclipse, that's something totally separate from that. My bad. But anyways, go ahead, draw each of these, label them as such. We're going to discuss spring tide and neap tide in more in depth tomorrow, and we'll see this chart again tomorrow. To finish up for the day, though, guys, really quick, let's go ahead and check out lunar tides and solar tides. Key thing to note, again, make sure you write this down on page 9, is the moon has the largest effect. So people would often think that the sun has a greater influence on the tides in the earth because the sun is just much larger, but that is actually not the case, because the size of each of those objects has less to do with it. It's more has to do with the proximity, the distance that those two objects have with the Earth. And with the moon being so much closer than the sun, it has a greater influence and a greater gravitational pull in proximity in influencing those tides. So lunar tides, the moon has the greatest effect, the largest effect, despite its small size, since it is closer to the Earth. Solar tides, the sun has a smaller effect, despite it being large, because it is super far away. It's really far away. So always know the moon has the greatest influence over our ocean waves, over our tides, in comparison to the sun. Okay. Last video I want you to answer for the day. What if there was no moon? What would happen? Would there be no tides? Would the Earth would there be a chaotic situation on the Earth with our climate, with our sea levels? Go ahead, guys. Go back to our YouTube links that I post on Edsby, and I'd like you guys to watch all of this video. What if the moon disappeared? Hmm. So again, it's on you to watch the rest of that. Really interesting stuff. Again, you guys know I never try to show boring videos. I always like to show really exciting, cool videos. So nothing boring, always exciting. And with this being said, the moon disappearing, a lot of bad things could happen especially with regards to our tides. If there's lower, just calmer tides, that may drastically impact a lot of our sea life and our marine aquatic life. So you'll find that out more when you watch all this video. Also influences the visibility of our sky. No moon kind of lighting up the sky, especially with those full moons, easier to see, makes it a lot easier to see the stars and the maybe other galaxies, other solar systems. So really cool stuff there. Let's go ahead and finish up for the day, guys. Again, make sure to answer that on your page 9, or I believe maybe page 8 if we wrote the video questions there. To our last question of the day. Okay, so back to our laws, right? Got to know the Kepler's laws. Got to know the Newton's laws, Isaac Newton's laws, right? Which scientific law discusses force? Again, hence got to use the force. Why I put Yoda up there for Star Wars. Mass and acceleration. So it involves force, mass, and acceleration. Think of force equals mass times acceleration. Is it A, Kepler's second law, B, Kepler's third law, C, Newton's second law, or D, Newton's third law? The correct answer, guys, is going to be C, Newton's second law. All right. Well, guys, keep up the good work. If you have questions, let me know. We should be working on keeping our notebooks up to date each day and completing that lab, the moon phases lab, and submitting it hopefully by Friday or by the end of the week as well. Again, Mr. Campbell signing out. If you guys ever have any questions, feel free to let me know. Stay on track, stay focused, and we'll just take things one day at a time, 1 week at a time. Mr. Campbell signing out.